I know. That's the one because I did review it this morning, and like that's the one I was like having a hard time like deciphering which one it was. What do you guys think?
So the hold on, let me find it. Age in years of randomly selected in a parking lot. That's still like, even though like they're handling numbers, they're still putting them into categories, if that makes sense. They're not counting the cars per se.
But it's more of putting them in groups of their age, right?
Yeah.
Okay.
Okay. Awesome. Thanks. So then it's B and C are both categorical.
Yeah.
Cool. Okay, can I read question 3? The mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores was 112. Which of the following statements are true? 100 is a parameter, right? The statistic is 112.
Mm-hmm.
Yeah.
Is that what you got, Olivia?
Yeah.
Okay, cool. Oh, Kaylee's here. Hi.
Hi.
So, Kaylee, I don't know how long you've been here, but did you get our answer for question 2?
Yeah, she said it was the second and third one.
Yeah.
Okay, yeah. I was trying to find where y'all were at.
Okay, so now we're on the 4th question. Does anybody want to read it? Okay, I can read question 4. Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' responses to a proposed increase in property taxes? Which one's the one where you put them into like similar groups and then take a simple random sample from that group?
I want to say it's stratified, but I don't know.
I think if I go to the review, it was there.
Yeah.
There you go. A stratified, you're right. Yeah. I think that one. What do you guys think?
I agree.
Because they already put them into 4 categories.
Yeah. It's
so
just
then
having to choose it, right? So
yeah.
Randomly. Okay. Kaylee, do you want to read number 5?
Yeah. When designed experiments are conducted in a public school system, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected class. Which type of sampling scheme is implemented?
I almost feel like it's the same thing because they took all the 4th grade teachers of an elementary school and then they're choosing randomly within the 4th grade.
I feel like there's one that's really close to the stratified though, isn't there?
Yeah, there's one where they...
It's like more, would it be a systematic where it's more like kind of uniform? Do you know what I mean?
Okay, so that would be like if they were choosing like every 5th student in the 4th grade.
Oh, okay. The systematic one.
Yeah. Maybe even a cluster sample, because a cluster sample is all items in one or more randomly selected clusters or blocks. So did they randomly select fourth grade?
And it's kind of like if they're taking all the students in the selected classes, wouldn't that be like a cluster of the students?
Yeah, I would say cluster. That makes more sense. Because it even says that randomly select teachers of, say, fourth grade. So it was a random selection of the fourth grade teachers.
Mm-hmm.
So a cluster is question 5.
I can read number 6. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? Wouldn't it just be a simple random sample?
That's what I thought too. What's a stratified random sample? Well, that's the same thing, how where they were into groups or whatever. Okay, I would say like simple random sample.
Because that's like I guess like the best way or whatever to choose someone randomly, right?
Mm-hmm. Right. Okay, I can read question 7.
Okay.
A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. They then took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented?
Wouldn't it be a simple random sample? Or
Would it be like a voluntary response?
okay.
I would say it's,
what that was.
I know, me either. So I'm thinking it's either stratified, or
Or would it
voluntary.
be systematic because they're taking the Democrats and the Republicans and then choosing 100 from that list at random, like the random sample? Instead of like choosing all like registered voters, they split it into between Republicans and Democrats. So wouldn't that make it systematic, and then random is choosing the 100 at random, right? Or is that, I don't know.
Okay, well, the systematic one, the way a systematic is usually very obvious because it's like every 10th student, or every,
Oh, okay.
like that's what the one that's kind of obvious to me. Simple random sample, it can't be that one because it wasn't just, random selection. I would think it's either
lesson 1 or lesson 2.
it's lesson 2.
Okay, let's see.
If you go to lesson 8 on the review and just push on the summaries button, it'll show you like a summary of all the lessons like in one page, and it's super easy to to kind of recap on everything that was covered. So
Okay.
I think like it's either cluster, satisfied, or stratified, I think, which is hard to determine or distinguish.
Oh, so it would be stratified because it says divide state into similar groups and then takes the simple random sample.
That's what I thought too. I feel like we're doing kind of a lot of stratified, so it makes me doubt, like, well, we're kind of doing a couple of...
I can see that. Okay. So now we're on to number 8. Right?
Yeah.
I need to go sit over there, baby. Can't go sitting on my back.
I like sitting there.
No, please go sit over there.
Allie?
I'm gonna lay on you though.
Okay, we'll lay on you right here.
To find the mean, was it in Excel? Was it the sum? Or no? It's median, right?
To find the mean?
Yeah, isn't it? Wait, I forgot the
So the way I do it
bridge.
is we already had a spreadsheet. You remember that they gave us? It's called like quantitative descriptive statistics. And I basically just copy and paste my information on the first cell.
Uh-huh.
And it gives me like all the information. Like it's already all there. It gives you the mean, standard deviation, the variance, all the Q's or whatever.
So what did you guys get for number 8?
I'm still trying to figure it out. Oh shoot.
Me too.
Which number are you guys on?
Number 8.
Okay, okay. Cool.
I got 4.771.
Yeah, that's the correct answer.
Okay. 4.771.
Yeah.
Okay. Okay, so I'm figuring out the standard deviation.
I got a 1.912.
Same here.
So you got which one? 1.912?
Yeah, for number 9.
Okay, I got the same thing.
Okay.
Okay, so for question 10, start by creating a histogram of the amount spent in the Crossroads purchases, then mark the following statement as true or false. I created a histogram representing the amount spent in Crossroads. I did because it's already on the Excel spreadsheet thingy. So I'm just going to put true.
Okay. Do you want me to read the next one?
Sure.
Okay. Jessica Mira and her research team measured the body temperatures of a sample of diving elephant seals. A thermistor was placed at a specific location on each seal to measure body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated the typical body temperature of each cell at the time they initiate a dive and called this the representative temperature of the seal. Thermistors were placed in the hepatic sinus of four of the seals, named Botto, Roberta, Larry, and Pear. The seal's body temperature at the start of the dive was calculated to be at so the X over with the line over that, is that
That's the mean, right?
is it the mean?
Or am I wrong?
The mean, or if it was the standard deviation, but
I think
it would make sense if it is the mean.
Yeah, because then you would it's 37.91, right? Like the first number minus the mean, and that's going to give us our deviation from the mean, right? Or am I off?
So you calculate the deviation from the mean. You're trying to figure out standard deviation, right?
Right, like the deviation from the mean. Yeah, the standard deviation.
That makes sense.
But you do the deviation from the mean column.
Yeah, but how do we even do the deviation from the mean column? The x minus x with the line on top? Is it just 37.91 minus the mean of the data?
Exactly. Exactly.
Okay.
I'm just gonna put it in Excel.
So right now we're figuring out the mean pretty much.
Mhm.
Okay. So the mean is 38.075.
Mhm.
So then our first answer for A is 37.91 minus that number I just said, 38.075.
0.075. So
Yeah, 38.075. Which I got negative 0.165.
negative 0.465.
Hold on, negative 0.165.
Oh, really? Let me try that.
Yeah. What did you guys get? I could be totally wrong.
37.91 minus 38.075, right?
Yes.
Oh, okay, I wrote something wrong on that. I got the same thing.
Okay.
Negative 1.165, sorry.
What did you get, Olivia? Did you get the same thing?
Yeah, I did.
Okay. Okay, so for question 12, what is the value that goes in the position mark B? Okay, so now we're basically doing 37.25.
Mhm.
Minus
38.075. Did you guys get negative 0.825?
You square that.
Okay.
yeah. So yeah, I did get negative 0.825, and then you square that, like Olivia said, and that'll give you your standard deviation.
So I don't think I have a calculator that will square. Let me see. Okay, I do. So then I end up getting 0.680 or 681.
Mm-hmm. I got 68. Oh yeah, 681. Yeah, if you round it, yeah. So negative 0.681.
Wait, I didn't get zero. Negative though.
Okay, so it's negative 0.681, right?
No, when you square two negatives, when you multiply them by each other, they become positive.
Okay.
So
I don't know why my calculator did that then. That's weird.
it really does the same exact thing. So
That's crazy. I didn't even think about that. Thanks.
mhm.
Okay. What?
Okay, so question
would be
13.
equal to the sum of the numbers in the squared deviations column?
It's either variance or standard deviation, maybe.
So like I'm going off of my submitted answers, variance, and I got it wrong. So
Yeah.
I'm guessing that none of these are correct.
Okay.
Standard deviation, you still have to do another step.
Okay.
Yeah, I remember doing that actually to get the standard deviation.
Kaylee, do you want to read the next question for us?
14.
Yes.
What is the standard deviation of these temperatures? Round your answer to 3 decimal places.
Oh, for the above?
Yeah, so I did it on the Excel sheet and it already gave me the answer. Do you guys want to work through it, or do you want to go off of the Excel?
Yeah, I'm gonna
go.
What was that?
I'm just gonna get mine from Excel as well.
Okay.
Hey guys, I have to dip out early, okay?
Okay.
All right, thanks. We'll see you later.
Bye.
Bye. So I got 0.715. Are we allowed to, we're allowed to use this spreadsheet, right? Because I think it said you're allowed to use like the tools that you've been using
Yeah, I think
with
we're
Excel.
allowed to. Okay, so I also
Okay.
got the same.
So, okay, cool. About halfway through. So that's good. Under certain conditions, the standard deviation can be negative. That's false, right?
Yeah.
Okay. I'll go ahead and read the next information.
Okay.
In the study, the researchers placed thermistors, temperature sensors, in the 3 seals named Chick, Starburst, and Patty near their spinal cord and brain in the extradural vein. They placed thermistors in 6 other seals named Sir Richard, Jerry, Sammy, Nut, Jonesy, and Butler in their aorta. I don't know how to say that.
Yeah.
The largest artery in the body. Finally, they placed thermistors in 4 other seals named Bottle, Roberta, Larry, and Purr in their hepatic sinus. The results from the study are summarized in the table below. All right. Which location? Oh, sorry, go on.
Oh no, I think it will be the hepatic sinus because that mean is closest to the mean that we got from the other one, right?
Yeah, that makes sense.
Wait, is that
So
correct?
hepatic sinus. Oh, wait, we didn't start recording, did we?
Oh yeah, I think I did.
Oh, you did? Oh, okay, cool.
Let me make sure though.
I was like, wait.
Yeah, it's broadcasting.
Okay, cool. Awesome, thanks.
So I was doing this based off of the mean from one.
I'm sorry, say that again?
So I was doing it based off of like the mean from the last like example. Wouldn't it be based off of like whichever one has the smallest standard deviation is the most consistent?
Yeah, that would be true because then the least standard deviation means it's closest
Like
to
they're
the
the
mean, right?
Yeah.
Which location results in the most consistent temperature movement from one slope to another?
So would it be the extradural? So that's the smallest standard deviation.
Yeah, because that would be the most consistent. So yeah, that's true. I'd go extra. Okay, black spots. The third quartile. I'm always bad at these. I always have to double and triple check my notes. Is it 8?
Oh, for the third quartile. Would be 8, yeah.
Okay, because there's the first is on 2, the second is on 4, then it's the mean, and then it's the third quartile, right?
Yeah.
Okay, cool.
I believe so, at least. Okay. I can read 18. What percentage of the data lies between 4 and 8 hours? Note, list the number as a percentage, not a decimal, but don't include the percent side.
Okay.
Okay.
So 4 and 8 hours would be between the second and third quartile, which is, I want to say 50%.
I want to say that too, but I'm not sure.
Because basically 25% is between the first quartile
and the second, right?
The second, yeah. And then the other 25% is between the third and the fourth. So 100 minus 25 minus 25 would be 50.
Okay, let's try 50 then and see.
Okay.
We're almost done.
Mm-hmm.
I'll read the next thing. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrates above 10 ppm are considered a health risk for infants less than 6 months of age. The City of Rexburg reports that the nitrate concentration in the city's drinking supply is between 1.59 and 2.52 ppm, and values outside of this range are unusual. We will assume the mean minus 2 times deviation is equal to 1.9 ppm, and the mean plus 2 times the deviation 2.52 ppm. It is reasonable to assume the measured nitrate concentration is normally distributed.
Am I done with your meeting, Mom?
No. All right, estimate the mean of the measured nitrate concentration in Rexburg's drinking water. Do you remember how to do this?
I don't. So do we know the standard deviation?
I don't think it. Hold on.
It doesn't give it, right?
No, it didn't give it to us. It just gives us two equations, and we have to figure out the
mean, right?
Yeah. So the mean is like the little U symbol. So I'm thinking we're solving for the little U symbol, right? Is that what we're solving for?
Yeah, but it should give us the standard deviation then, right? To be able to solve for the mean.
It didn't give it to us though. So I'm thinking, okay, I know what we're gonna do.
Okay.
We're going to subtract, at least this is what I would do. I would subtract the mean. Like pretty much you're switching 1.59 and the mean, they're switching spots. So it's going to be 1.59 minus, 2 standard deviation or whatever. Allie, it's okay. There's not enough water in there. Sorry. Okay, so 1.59 minus 2 times the mean equals negative 2.52. Oh, no, sorry, positive 2.52 plus 2 times the standard deviation. And we're going to set that equal to the mean. It'd make a lot more sense if I can just show you. Just give me 1 sec. I'm going to get a piece of paper and a...
Okay, because, yeah, I'm a little bit... Do you remember what this was from? I don't even remember having something like this.
I don't. Sorry. I just woke up right before the meeting.
Oh, you're fine. Are you, where are you living at?
I live in Texas with my family for right now.
Oh,
But
that's
I
nice.
got called into work yesterday and didn't get home till 2, so.
Oh, goodness.
I know. I'm so
Where do you
tired.
work?
I work at the ER at our
Oh, wow.
hospital here.
As, like, are you like a nurse, medical assistant? Or
No, I'll get you breakfast in just a sec.
Sorry, I couldn't hear you.
I'm
Who,
an
me?
ER tech.
Oh, you're an ER tech? Is that what you said?
Yeah.
Yeah, that's really cool.
Yeah.
I'm sure it's stressful too, though. I can imagine, especially if you're like on call and stuff.
It is. And it's 12-hour shifts, so it's not like I get any time to do homework when I'm there
Oh,
during the day.
yeah, that sounds crazy. So you normally, are you a completely online student, or do you?
No, I'm completely online just because I never know when I'm going to work.
Oh, okay.
So.
Okay, I'm trying to think what's the best way to show you guys. Negative 1.59 plus U minus 2 equals 0. And then negative 2.52 plus 2 plus 2 equals. Okay, so let me go to the camera thingy. So can you guys see what I wrote? Like
Yes,
right here?
Oh.
Okay, so basically what I did was moved 1.29 to this side, right? So you have to subtract it
Uh-huh.
pretty much. Okay, so that's like the first step. So far we have negative numbers on this side, okay? Because we subtracted it over. So I'm going to do the next step right now. Okay, so this was the next step. Oops, just kidding. 1 second. It's hard to explain. So then we subtracted the mean to the other side. I don't know why I got so bright like that all of a sudden. Okay, so we had the mean here, right?
Yeah.
But we had to move it to the other side, so you have to subtract it. So I moved it to this side.
Okay.
But since we don't want a negative mean, we're going to have to distribute this negative to everything on the other side.
Okay.
So once we do that, it's going to be 1.59 plus 2 times the standard deviation equals the mean, and positive 2.52 minus 2 times the standard deviation equals positive u. So our main equations that we end up with are these two right here. 1.29 plus 2 times the standard deviation, 2.25 minus 2 standard deviation.
Mm-hmm.
So those are like our two
How do we-
equations.
How do we find the deviation though?
So we're not really, I think,
Because wouldn't we have to know that to be able to solve for the mean?
we're basically just trying to solve for a variable because they didn't give us any information. I remember doing that last time too, is you're basically solving for a variable. Like we're acting like as we have x and y, and we're trying to figure out what x and y equals.
Okay.
So we're going to set the two equations equal to each other. And we're going to have 1.59 plus 2 times the standard deviation equals 2.52 minus 2 times the standard deviation. I know it sounds weird, and I'm trying to explain it as best I can, but it's kind of
No,
hard
it makes
to.
sense. I just
Okay.
remember. I mean, I kind of have forgotten.
Yeah, it's been a while.
I think it's been probably like 4 or 5 years.
Yeah. Right, so I got an answer for our standard deviation. I know what it is. So we would basically plug that back into our original equation.
Mm-hmm. So the original one that they gave us, or the one that we
The original that they gave us.
Okay. So did you find the standard deviation based off of the equations that you did?
Yeah. So yeah, I was able to simplify it, and I got 0.2325. 0.2325.
Okay.
So go ahead and substitute that in for the standard deviation in both of the equations. And if we get the same mean, then that means we have the right response. If we get two different means, then we did something wrong.
Okay. Okay, so for like the first equation that they gave us for the mean, I got 2.055.
Same here.
Okay, perfect. And then for the next one, so I
Bless you.
have to go in just a few minutes. But do you think I'll be able to? You guys are still able to like copy the thing, right?
Copy the what?
The link to broadcast it, or
Yeah, I think so. I think we can just cut it short because I don't know how to do the live broadcasting. I've tried it, and I need somebody to like teach me how to do it because I've even Googled it, and tried to watch stuff, and I don't know why it just never.
so you
Never
remember
works
when we had
out.
to make like the video for like the introduction or whatever?
Uh-huh. It's like
It's
the same
really,
thing.
yeah, it's really similar to that. Actually, I think it's the same thing as that, but you have to like add it will like have a thing where you can add people. But I know Emily said last time that the like add button wasn't working for her. So
I think that's what happens to me sometimes. I can't add people or whatever. Well, I don't know. Before you have to take off, so I got the responses were the same for me. So I think the mean is
yeah,
what?
same.
So 2.055.
Yeah. I can probably do one more question, I think.
Okay. So we're running to 3 decimal places, so that should be right. 2.055. Okay. So estimate the standard deviation. So we got the standard deviation already.
So would we do 2.33 if we're rounding it to?
Yeah. So
Okay.
0.233.
Between what two measured nitrate concentrations to approximately 68% of the data values lie?
Ugh. Okay, so we got the mean, right? And we have our standard deviation. So it's going to be 2.055 minus 0.2325, and that's going to give us our first standard deviation.
Okay. So it's equal to 1.823.
Yep,
One. And then
that's what I got. Oh, perfect. It's actually a suggestion, so I think we're on the right track.
okay.
So I would say it's the last one.
Yeah, we don't.
Okay, have time for one more. I can read it.
Yeah, I think I should.
Okay, the
I'm
admissions
actually like I just have to go to work right there, so it's fine.
Okay, cool. Okay, the admissions committees for most Masters of Business Administration programs require the graduate management admission test as part of the application for new students. It has been shown that the scores on the GMAT are normally distributed with a mean of that and a standard deviation of that. The minimum GMAT score required for admission to the MACC program in the School of Accountancy at BYU is 500, but it is rare for students with scores less than 600 to be admitted. Okay, So I'm just going to write down that information real quick. The mean is
542.3, right?
542, yep, 0.3, and the standard deviation is 120.54. Okay, and the minimum, okay, we can do that later. Okay, so what is the probability that a randomly selected student will score above 542.3 on the test? So basically we're going to,
You have to find the z-score, right? Or no?
yes, yeah, you're right. So we're going to have to take the mean of the means. Hold on, let me write down the equation because I remember better that way. Okay, so it's going to be 542.3 minus, 542.3. Oh, we're basically, yeah, you're right. We're just finding out the z-score, like, flat out. So isn't it like the mean divided by the standard deviation?
Yeah.
Okay. So it's just 542.3 divided by 120.54. So we get a z-score of like 4.49.
4.49. Oh, this is going to be like a very... do you have like the applet open?
Yeah, I'm about to open it up right now. I have it bookmarked.
Oh, that's smart. I should do that too.
Okay, so is that our z-score then? What I just said, 4.49?
I'm thinking it's kind of high though.
I know, that's what I thought too.
Because I feel like it's going to give us a probability that's super small.
4.498. See what that gives us. Yeah, it's like super small. So did we do it right? I think that's how you do it, right?
Maybe what we need to do is we need to subtract the 600. I don't know though. 600 minus the 542.3 and divide it by the 120.54.
Okay, we'll score up.
I don't know if that's going to give us the right answer though.
Okay, the minimum is 500, but it is rare for students to score less than 600. We'll score above. It would have to be a higher probability because it's like,
That's what I was thinking. Like,
it's rare for them to score less than 600 is what it says. So I would even maybe, what if it's 0? Like, because remember in one of the videos, it's one of the probabilities was 0 because the probability, it gave us the same thing, like, you know, that little E thing with like the negative number or whatever.
oh, is that one? Okay, I couldn't figure that one out, but that makes sense.
So I think it's,
So I got so if I did that, I don't have the applet open. Do you think you could put this number in and see if it's correct?
yeah, sure, go ahead.
So I got 0.479.
0.479.
Yeah.
Okay, so with that, it gives us a probability of 0.3160.
So that'd be like 31%. Wouldn't that be?
Yeah, maybe we should try that. 0.316.
Okay.
Yeah, I double checked 0.3. And it's also just shaded to the right, right? Because it's greater.
Yeah. So it'd be
Okay,
shaded.
so everything to the right is shaded. The center and the left are not shaded.
Okay.
Okay. What is the probability that a randomly selected student will score below 600?
Wait, okay. Maybe I did that wrong then.
So wait, what did you get for 22?
22 was 0.316.
Maybe you are right that it is 0.
Okay, because it said it's rare. So I'm thinking like if they're going to score below 600, like maybe it's 0. And then for the next one, it's going to be...
It would be the 3.16 because that's what I did.
Okay, so 0.316 for the next one.
Okay.
It's a doozy. Okay, 1 second. Ellie, you want to get apple slices from the fridge or grapes out so you and Sarah can snack on those? I'll help you open the apple slices. What? Okay, just get out the apple slices for now, okay? Okay, sorry, Mom.
For number
Sorry, I'm
23, it would be anything that's less than the,
Oh.
and the next one would be 0.316.
Okay, everything that is less than. This is the answer for anything less than.
Okay.
0.684. 0.684. And then the other answer was, what did we say?
316.
316.
316. Okay. Let me double check the first. Okay, 0.684. So that's good.
Not in there, Mom. You lied.
They should be. Hey, why don't you get some fruit snacks out for you and Sarah then? Go get the fruit snacks. Sorry, my kids are hungry, so I'm just like, just eat candy. Very restless. Okay, the 10th percentile. Oh, so don't I just put 0.10 on the thing, the applet?
For the, yeah, I think so, for the Z-score, right?
Yeah.
And then it's just whatever.
Okay, so I put in the 0.10, and where am I shading?
I'm trying to remember if it, wouldn't it be all of it?
I don't know. Hold on, let me see. Find corresponds to the 10th percentile.
Maybe it would just be to the, everything to the left. Right?
Even the center? Even the center? No, because you know what? If I just put in the probability of 0.1, it automatically shades it for me. Like if I shade the center and the left or whatever, if I put in 0.10 and push enter, it'll just give me the right.
Okay.
So the z-score of that is 1.282.
1.282.
Mm-hmm.
And then we need to find the problem. Oh my gosh. I always forget.
So 90th. Okay, let me go to the review real quick and let me go look at the lesson. Okay. Okay, the probability applet shows us to use z-scores to calculate proportions, probabilities, and percentiles. So then would I just put 90% on the thing, like 0.9, and then
Yeah, and then I'll give you the
it gave me 1.282.
as well.
Is that different than our last answer?
Oh, it's the same one. But it kind of makes sense because it's like the outliers, right?
Mm-hmm. Okay, let's put 1.282.
Okay.
And I know I'm putting in the numbers right. Not. So 25 and 26 are kind of up in the air a little bit. The first quartile of the distribution of the GMAT scores.
I remember doing that, but I don't know if there's another step after that.
I'm trying to remember. Ellie, why don't you choose something to watch, please? Oh, I just tossed it to you. Okay.
We can just go with that and see if it's correct or not.
For what, the first quartile? Or
Yeah, for both the 10th and 90th percent.
Oh yeah, I'm okay with that. I'm trying to figure out question 27 now, or trying to find the first
Oh.
quartile of the distribution,
You know how? Oh, actually,
which is the first 25%, right?
I think if you plug it into Excel, you can actually find it. Let me see. I don't know if you need the numbers though.
I think I'm just gonna, let me see. Oh, I don't think you can.
Dang it, ask for the array.
Yeah, you need the data. Okay, hold on. So what was our mean?
Our mean for that was
Are we using the same data?
yeah,
It's been a long time.
it's
GMAT squared.
542.3 for the mean.
Hold on. Let me try inserting it manually. 542.3.
Yeah,
542.3. Okay, what was the standard deviation?
the standard deviation is 120.54. Actually, this makes sense. So we have at the 10th percentile, we have the 1.282, right? And then our mean is, this doesn't make sense actually, never mind. I take that back.
Okay, the first quartile is going to be the 25%. If we have the 90, what was the roll? 97, 95, and 90, or 86 roll?
Yeah, is it like 0.7 or something?
Yeah.
So I should actually go into work. I'm like 10 minutes late, but
Oh gosh. Okay, so if you want, we can just stop the recording, and I can text you guys in the group message like what I get. I can go back and review too, like for questions 25 and 26. You know, like better study what those are, and I can tell you guys kind of like how I did it. Or
yeah, I'm looking to the same. I probably won't be able to do it until like later tonight. But do you think, are we allowed to just like leave the quiz, or do we have to submit it? Do you know?
I think we can leave it.
Okay,
I think
that
because just save your answers. Make sure to save all your responses, and I think you can come back to it. And even if you wanted to meet up later too and finish going over it, we can do that. But I will go ahead and finish the quiz, and then if you want to meet up later, I can explain to you like what I got or whatever.
Okay, perfect. And I'll it's the same. I'll let you know if I have questions when I'm doing it.
All right, sounds good.
Thanks, guys. I'll see you later.
Thanks. Bye.